Hello everyone, today we're going to look at Riemann sums. So what we're going to do is we're going to approximate the area under a curve by using what's called Riemann sums. There are several types of them, but we're going to focus on two of them called the upper and lower Riemann sums. So suppose we want to approximate the area under this curve. So it's y equals 16 minus x squared from 0 to 4. What we're going to do is we're going to divide the x values into, in general, so many subspaces. So we're going to do 4 in this case. So we're going to divide the x values into 4 equal segments. So since it's from 0 to 4, each of these segments will be a length of 1. And then we're going to create rectangles out of these. And as I said, there are several different ways we could do it. We could do the height of the smaller endpoint. So if I look at my first rectangle or part of my rectangle here, I have my base is the length of 1, and then my sides are slightly different. I've got up to my function on the left and then up to my function on the right. So I'm going to, at some point, I'm going to create this as a rectangle by cutting off the top part. So where we decide to put the top of the rectangle is going to depend on what type of Riemann sum that we want. So if we use the smaller of our two endpoints, then that's called a lower Riemann sum or an inscribed rectangle. So it's inscribed because it's inside of our function. So that would look like this. I'd be taking the smaller of my two and making it into a rectangle. So this is the lower. I could also do the larger of the endpoints, called an upper Riemann sum, or circumscribed. So circumscribed means it's going around the object. So for this rectangle, I'll do the upper Riemann sum. So I'm going to take the higher of my two endpoints and create a rectangle. So this would be an upper. I could also use the midpoint. So for the middle one here, or this third one, I'll do the middle. So I'm just going to go halfway up, and I'm going to use that as my height. So that would be the middle. I could also just always use the right endpoint, or I could always use the left endpoint. And those are the 5 main Riemann sums that we look at: the lower, the upper, the midpoint, the right, or the left. And again, we're going to focus on lower and upper. And generally, you choose one of them for the whole set. So I'm not going to do one of my rectangles as lower, one of my rectangles as upper. I do all my rectangles as lower or all my rectangles as upper, etc. So I'm just giving you an example of what they all look like. But again, we're going to focus on the upper and the lower, sometimes called the inscribed or the circumscribed. So below here are the pictures of using the upper Riemann sums and using the lower Riemann sums. So this side is the upper. So for every rectangle, again, I'm going to take the higher of the endpoints. And they happen to be on the left because my function is decreasing. For the lower Riemann sums, again, they happen to be the sides on the right because, again, my function's decreasing. So here, my height is the lower of my two endpoints. And then my rectangle from 3 to 4 is actually just 0 because my right endpoint is 0. Okay, so I've got two different ones here, again, the upper and the lower. Each rectangle has a width of 1, and we're going to approximate this area by using these rectangles. So an upper Riemann sum is always going to have some extra pieces here. So this will always be an overestimate of my area. But my lower Riemann sum is going to be missing pieces. So it's going to be a lower estimate of our area. So that when I find both of them, I know the area should be somewhere between the two. So my lower Riemann sum is going to be some value, my upper Riemann sum is going to be a larger value, and the actual area is somewhere between them. So we'll do it out for this one and see what we get. So what I'm going to do is I'm going to find those endpoints. So again, we had from 0 to 4 in 4 segments, so that's going to give me my endpoint values of 0 through 4. So if I just drew my picture here, here's 1, 2, 3, 4. So I'm finding those y values by just plugging in my function. So if x is 0, I'm at 16. If x is 1, I'm at 15, right? X minus 1 squared. At 2, I'm at 16 minus 4 is 12. At 3, I'm at 16 minus 9 is 7. And then at 0, I'm at 4. So if I want to find the areas, again, I'm going to just take length times width. Each length or width or whichever direction you want to call it is 1. So I'm going to be doing 1 times, if I want the upper rectangle, I would have 1 times 16 for my first rectangle. For my second rectangle, if I'm doing again the upper, I would have a 1 by 15. My third, I would have a 1 by 12. And my fourth, I would have a 1 by 7. So 1. So what I'm going to do in my next little thing here is I'm just going to take out all my 1s. So I'm going to do 1 times and then add up the heights of my 4 rectangles. So that's what we have here. One dimension, again the base or the width or the length, whatever you want to call that, of the rectangle, times the heights of those 4 rectangles. And again, those are the numbers from the upper Riemann sum. If I add all those together and multiply by 1, I get 50. And then I'm going to do the same for the lower Riemann sum. So again, for that lower one, we're going to have the 15, and then the 12, and then the 7, and then the 0. So I'm taking these values. And again, those are just the lower of the 2 consecutive numbers. Okay. When I add all those together, I get 34. And again, the lower Riemann sum is always a lower estimate. The upper Riemann sum is an upper estimate. So I know that the actual area is somewhere between those 2 values. If I want to get a better approximation, then I'm just going to use more rectangles. If I have my picture and I divide it into smaller rectangles, then the part that I'm either adding, if it's an upper estimate, or subtracting, if it's a lower estimate, are going to be smaller. So those kind of extra pieces will be smaller. My upper Riemann sum will get lower. My lower Riemann sum will get higher. And so the difference between the 2 is going to get smaller. And again, I know that the actual area is between those 2. So if my upper Riemann sum gets lower, my lower Riemann sum gets higher, then I'm getting closer and closer to the actual area. Okay, and that's kind of the idea behind this. So here we're going to approximate the area under the curve y equals x from x equals 0 to x equals 3, and we're going to use 3 rectangles. What we're going to do is we're going to use both the lower and the upper Riemann sums, and then we're going to compare to the actual area. So if we notice, this is a very lovely triangle. So I know the actual area under this curve. So I don't have to use Riemann sums because I don't have to approximate it, but I want you to see, how good of an approximation it is. Again, we're only using 3 rectangles, so it's not going to be fantastic, but we'll see how it works out. So again, here is a picture of our lower Riemann sum and our upper Riemann sum. So again, we're going from 0 to 3, and we're going to make 3 rectangles. So we're going to have from 0 to 1, 1 to 2, and 2 to 3. And for our lower Riemann sum, we've got 0 and 1, so the lower is 0. From 1 to 2, we have in height value 1 to 2. 1 is the lower. And in our 2 to 3, we have a height of 2 and a height of 3. And again, the lower is the 2. For the upper, it's the opposite. So from 0 to 1, the higher endpoint is 1. From 1 to 2, the higher endpoint is at 2. And from 2 to 3, the higher endpoint is at 3. And then again, our lower Riemann sum is kind of cutting off these sections here. So it's a smaller estimate than the actual area. And for the upper Riemann sum, we're adding in this area here, so I know that value is going to be too high. But again, the actual area is somewhere between them. So here is just our list of x and y values. Again, y equals x, so they're all the same. And we just kind of went over how to find those values. So for the lower, we've got, again, the width is 1. So that's where this 1 is coming from. Each width or base of our rectangles is 1. And then the heights, again, are 0, 1, and 2. So we're going to add those guys together. And that's going to give us a lower estimate of 3. For the upper, again, that base is still 1, and our heights are 1, 2, and 3. And that gives us an estimated area of 6. Okay, so I know I know the area is somewhere between 3 and 6. But again, that is just a triangle, and the area of a triangle is 1/2 base times height. The base is 3. The height is also 3. So 1/2 3 times 3 gives us 4.5. And that actual area of 4.5 is between our 3 and 6. So I know that I did the area correctly, it makes sense. It is between the lower Riemann sum and the upper Riemann sum. For our last example, we'll approximate the area under the curve y equals 1 minus x minus 1 to the 4th using 4 rectangles. We'll do both the upper and lower Riemann sums. So when we divide our divide our x-axis into our 4 segments, we're going to notice that each width is going to be 0.5. So instead of that 1 that we had before, our width or our base is going to be 0.5 each time. And then if we want the lower Riemann sum, we're going to have our first rectangle, our 2 points are at 0 and I believe 15/16, the lower of which is my 0. And in my second rectangle, I have 15/16 and 1. The lower would be my 15/16, so just our function at 0.5. For our third rectangle, again, the lower one is at 1.5. And then for our fourth rectangle, the lower one is at 0. So this isn't following the rule of the upper is always the right, or the upper is always the left, or the lower, or vice versa, because this function isn't just increasing or just decreasing, it's doing both. So this is what our lower Riemann sum would look like. So that's this guy here. And then if we're looking at our upper Riemann sum, then we've got our first rectangle has a height of the higher value, which is at 0.5. So we have this guy. And then both of our middle ones, the higher value is at 1. So they both have a height of 1. And then our right-hand side, or our fourth rectangle, has the height at x being 1.5. So these are our x and y values, and again I kind of mentioned them before, but we're just plugging x into that function, that 1 minus x minus 1 to the 4th. So our upper is again 1/2, that's the base, and then we've got the 15/16, the 1, the 1, the 15/16. And if we add all those together, we get 31/8. And then for the lower, again we've got a 0, and then the 15/16, 15/16, and 0. So that gives us 15/8. And again, our actual area is somewhere between those two. So let me know if you have any questions on just finding these Riemann sums. We're just approximating the area. Unless it's something like a triangle or a rectangle itself, we don't actually know the area at this point. So again, just let me know if you have any questions. Thanks.